Hi, we are Team Zero Bar. So for this final year project, we did interactive chart question answering using AI agent. So our first goal is to explore how today's main AI models understand interactive charts. In comparison with former research, they only focus on static visual and are closed systems. On top of that, we're also examining how much of that gap can be closed by feeding the model better instruction and tools without retrainings. Next is our end product. We develop an open benchmark which treats interactivity as a first class variable which compares three AI models under the same conditions. Most importantly, our project is transparent and reproducible. So, first, we search for data sets and charts. We use charts from free resources and make sure the data is from a reliable source. For example, this is from our World of Data website. We can see the chart and download its data. Then, we recreated the charts in D3. We reproduced the exact same charts using the data file obtained from the original source. These recreated charts are what we used in our project dataset. Next, we generated around 3 to 5 questions per chart.
Next, I will show how we run the benchmark. First, we run C1, which is our baseline condition. In C1, we only give the model the JavaScript file of the chart, the CSV dataset, and a question about the chart. For C1, we give no additional prompts and no additional tools. The purpose of C1 is to test how well the model can answer the question just by reading the code and data. This gives us a clean baseline on how the model performs, so that later it can be compared to how the model performs with browser interaction. To run, simply run the script like this. Once the benchmark has finished running, the script will output a CSV file which contains the chart, question, and the model's answer. Originally, we planned to do C2, which was prompt engineering. In C2, we would give the model better instructions based on the mistakes from C1. But after reviewing the C1 results, we realized that the models rarely made mistakes. Hence, we felt that the prompt engineering was not required. More importantly, in C2, we still only give the model code and data. It still cannot actually interact with the chart. Since our main research focus is interactivity, we decided to skip C2 and focus on C3 instead. So, this is C3, which is the tool augmented agent condition. In C3, the model is given access to browser tools such as Playwright. This means the agent can open the chart in a real browser and interact with it like a user. For example, it can hover over a bar to read a tooltip, click a button, move a slider, or apply an interaction before answering the question. We also give the model a structured instruction format, so the answer includes not only the final answer, but also reasoning, confidence, evidence, interactions performed, as well as self-checks. Similar to C1, to run, simply run the script like this. As you can see, we can see the model opens up a browser to figure out the answer to the question. We can see the model's interactions with the chart, which include clicking, hovering, dragging, and scrolling. Similar to C1, once the benchmark has finished running, the script will output a CSV file, which contains the chart, question, and the model's answer.
Let's see C1 and C3 comparison. For C1, the model only received the chart code, CSV file, and question. It could not directly interact with the chart. Because of that, the answers were not always consistent. For example, one answer was very short and direct, while another gave a much longer explanation. So even when C1 was correct, the format was harder to compare. For C3, the answer was more structured. The agent gave the final answer, reasoning, confidence, evidence, interaction performed, and self-check. The most important difference is that C3 can actually use the chart through the browser. It can hover, click, and filter. This lets us check not only the final answer but also how the agent reached it. So, C1 tells us what the model answered, while C3 helps us see how the model works. From the results, all three models did well on simple chart questions, especially when the answer was clearly shown as a label, tooltip, or visible value. However, we also found differences between the models. ChatGPT performed well on simple questions, but sometimes gave high confidence even when the answer was not fully correct. Gemini also handled simple questions well, but sometimes struggled with detailed explanations. It also gave very high confidence scores quite often. Cloud performed well on simple questions and gave better detailed explanations. It was also more careful with confidence scores. Overall, our results show that interactivity does affect model performance. C3 may not always be more accurate, but it is more transparent because we can see the reasoning, evidence, and interactions behind the answer. And that is all from our project. Thank you for listening.